This would be 3. Try to do as much math in your head as you can to prepare yourself for doing it later on the AP exam. So this would be 147. So A12 is talking about the 12th term. Remember, a sequence is just a list of right formulas or equations for those patterns. And so I'm giving you that equation, asking you to find the 12th term. Number 2 says to write the first 4 terms of the sequence, and I give you the equation. So the first 4, A3 and A4. So A1 would be 3 times 1 minus 4. 3 minus 4 is negative 1. 2 6 minus 4. 3 is 4. 3 times 3 is 9. Minus 4 is 5. And A4, 3 times 4 minus 4. 12 minus 4 is 8. So my first 4 terms are negative 1, 2, 8. And then the last one we have here, I'm giving you the formula. Find the 11th term. So A11 is 4 plus 11. Weird, we're not used to seeing a 5 after parentheses, but that just means we're multiplying by 5. So 4 plus 10 times 5 would be 54. 10 times 5 is 50 plus 4. Now, 2 types of sequences. We're going to talk about. The first one is arithmetic, not arithmetic. An arithmetic sequence is a number from one term to the next. And we call that number, does anybody remember what it's called? It's called the common difference. So if your numbers are getting bigger, your common difference would be positive. If your numbers are getting smaller, it would be negative. You'd be adding a negative number. And so arithmetic sequences, we're kind of relating this back to functions, but arithmetic sequences behave like linear functions. The formulas that we use for arithmetic sequences, when you kind of work it out a little bit, looks like something in y equals mx plus b form. If we graph the points on an arithmetic sequence, it would be a line. Okay. Now, we're going to look at, there's different formulas, different ways that you can write out a formula. This right here is what I taught you in Algebra 2. So, AN, just some term in the sequence, is A1. What's A1? What is A1? First term plus, what's D? The common difference, and then in parentheses we did N. So if you were finding the 30th term, you would plug in a 30. So N was your number of term minus 1. And that's all really we used in Algebra 2. But actually, I used A1 here, and that was N minus 1. You could do that with any term that you wanted. Like, for example, it could be A2 plus D, and then use N minus 2. So if I give you the second term, you could use that in your formula. it could be A3 plus D times n minus 3. Or A4 if you use n minus 4. So you could use any term that's in there, which is actually will come in handy. It'll make some problems easier that I made harder in Algebra 1 or Algebra 2 because I only showed you this one formula. Another formula you could use, so something else that will be new is the zero term. So we'll call that your first term. You could backtrack once and find the zero term. Okay, so easier. It's still the same thing as this. Like if I use A0 plus D n minus 0. Well, n minus 0 is just n. So that's just A0 plus dn. Or dn plus A0. The zero term. You just back up one. That gives you the zero term. So just different ways that you can write your formulas. So, you know, sometimes it might be more beneficial to use one way than the other. Okay. A little bit faster maybe. So number 4 gives me the formula for a sequence and asks me to graph it. So I'm going to do n, which is like my x, and then an. So I'm going to plug in my n to that formula. We'll start with 0. We'll find the 0 term. So that would be 3 times 0 plus 1, which is what? 1. So basically I'm going to plot the point 0, 1. And then my first term, n equals 1. 3 times 1 plus 1. What's that? 4. So I have the point 1, 4. 2. 3 times 2 plus 1 is 7. And then the third term gives me 10. I don't have enough space on my graph to do that. So just those 3 points are fine. But you can see if I connected them, I would have a straight line. That it's linear. This is, if I change that to x, that's like mx plus b. My slope is 3. My y-intercept is 1. So arithmetic sequences are just like equations of lines. Right. We do not connect them because remember, I don't have a 0.5 term. So I shouldn't have a line or a point in between there. So you just got 3 individual points. If yes, identify the common difference. So just by looking at this, does it look like a y equals mx plus b type? Is it kind of in that format? It is. So it should be arithmetic. It should be linear. But we this. So what I found on this, people are starting to use a for arithmetic. I always use an, like all across the board. When I taught it in Algebra 2, but these that I found, they were Brian Passwater's. He used S, and I think he did that for like just the sequence because we're determining geometric. So that's a little different than I'm used to and that you're used to probably. But either way, we're going to plug like 0, 1, 2, 3 into that. 6 minus 2 times 0 would be 6. 6 minus 2 times 1 is what? 4. 6 minus 2 times 2 is 2. 6 minus 2 times 3 is 0. So these are my first few terms. How do I get from 6 to 4? Subtract 2. 4 to 2? Yep. And then subtract 2 again. So since I've added the same number, I'm adding -2, I'm adding the same number across the board, we could say that yes, it is arithmetic. So yes, and my common difference is -2. Do the same thing for number 6. So I found these 4 terms and I looked at the difference between them and I had a is this arithmetic? Nope. If you remember back, there's been a couple of times early on in Unit 1, we looked at a table and had all those numbers were the same. We said it was linear. We're doing the exact same thing here. This is not linear. So it's not arithmetic. Arithmetic is linear. We found the second difference, and if the second difference was the same, we said it was quadratic. So if I found the second difference, I wanted to get to 3. 2. 3 to 5? 2. So this is quadratic. If you look at the equation, you have n squared, that's quadratic. Okay. All right, so number 7, is the sequence an arithmetic sequence? If so, write a general rule. Meaning I'm going to write the equation along with 1. But first we need to know if it's arithmetic. So is it? So whenever you're writing these rules out, I want you to write the help you remember options with the A1 because I said this one, the DN plus A0. Four, I'll be at -3. So you can n equal 1 plus d. My first term, A1, is 1. And that 1 minus 4. Term and put a 2 there. And then n minus 3. So minus 3. That was a little less. Either works. Sometimes finding it says find the 40 sequence. So we using the dn plus a0, the distributing and stuff. Right, so an equals 3n plus, if I went back 3, what would I be at? -1. So I really should have done -1. And I'm going to find the 46th term. I would have 3 times 38 minus 1. I don't see, when I do math in my head, I don't do this. I don't. And then I add them together. So the it says to find the 9th term of the arithmetic sequence. So write out the first few terms. Yeah, -7. So could you keep counting until you got so I'm going to show you the way to do it. So an -5. So dn, and then what would my 0 term be? $13, right? So plus 13. Because if I went up, this is going down 5. If I need to backtrack, I would need to go up 5. And so the 9th term, a9, would be -5 times 9 plus 13. -45 plus 13, which would be -32. Any questions? All right, number 10, let an be the arithmetic sequence with a3 equal to 8 and d equals -3. Find the expression for an. That means write out the rule. Your answer should be an equation. And use the expression to find a12. So in this one, I'm given the 3rd term. I could backtrack to find the 0 term, or I could do a3 plus d times n minus 3. Because I'm given the 3rd term. Like if I gave you the 40th term, you would not want to backtrack 40 times to get to the a0. Okay, so if I gave you the 40th, you would say a40 plus d n minus 40. So a3 we know is 8. We know my common difference is -3 times n minus 3. And I distribute. So I get an equals -3n plus 17. And so then my A12 would be negative 3 times 12 plus 17. Negative 19. Any questions? All right, several terms of the arithmetic sequence AN are shown below. Find an expression for AN and use that to find A17. So what I would do is I would list out my terms. So my first term, term 1 is technically 6, 4, 2. Be careful, don't start with 8 and then backtrack another one to find your 0 term. 8 is your 0 term. Like that's when x is 0, it's 8. So that's kind of where graphs would cause you to mess up. Your first term is actually 6. That's A1. What's my common difference? Negative 2. So it would be negative 2n plus 8. My 0 term is 8. You could this is easier. And so then A17 is negative 2 times 17 plus 8 is negative 34 plus 8, which is negative 26. Are there any questions? All right, got 2 more to do, and then we're going to stop with the notes. Let AN be an arithmetic sequence with A7 equals negative 9 and A14 equals to negative 23. Write it, find an expression for AN and find A17. You're not given your common difference. The easiest way would be to kind of treat this like you have the points 7, negative 9, 14, negative 23, and like do the slope, which is what I showed you to do in Algebra 2. So your common difference, you're going to subtract, like these are like your y values. So negative 23 minus negative 9, because in slope you subtract the y's on top, subtract the x's on bottom. And so 14 minus 7. This is really negative 23 plus 9, which is negative 14 over 7, which is negative 2. And so I am going to use a formula, and you can use either one of these terms in there you want. So AN, I'll do A7 plus D, and then N minus 7. You could have used A14 and done N minus 14. Or you could keep counting up 2 to find your 0 term, or your first term. A7 is negative 9. Then my difference is negative 2. N minus 7. we have negative 2n plus 5 as my formula, as my rule. It might say write a rule, write an expression, write the formula. And then I'm going to use that to find A17. Negative 34 plus 5 is negative 29. All right, arithmetic sequence with A3 equal to negative 5, 18 equal to 5. Find my expression and then find A10. So I need to do my common difference. 5 minus negative 5 over 18 minus 3. We're going to get a fraction here. 10 over 15 simplifies to what? 2/3. So I've got my A3, so I can use that. So I did A3 plus D times n minus 3. You could have used A18 and done n minus 18. A3 is negative 5 plus 2/3 n minus 3. So we get 2/3 n minus 7. How about we change that to find the 12th term? If you've already done it for the 10th, just leave what you have. But let's just find it for the A12. So you need to know 2/3 times 12. Do 2 times 12 and then divide by 3. 2 times 12 is 24 divided by 3 is 8. Because that would, I could see you having to do that without a calculator. When you're multiplying a fraction by a whole number, multiply that whole number by the numerator and then divide. Sometimes that's the easiest way to do it. Equals 1.